Hi, everyone. Let's take a look at number 8 on page 386 for grade 12 calculus and vectors. In two-dimensional space, or in R2, a square is determined by the vectors I and j. So vector I, which is a unit vector, and vector j, which is a unit vector as well. Part A, sketch the square. So immediately start with a diagram. And notice when I draw this diagram, I'm really focusing on quadrant number 1. And the reason is because if I look at the given, so this is part A, by the way, let me just write down A. If I look at vector I for your reference in two-dimensional space, it's going to be 1, 0. Likewise, for your reference, for vector J, that's going to be 0, 1. Now, it says sketch the square. So what you have to do is connect them. And if you draw the square, maybe in a third color, one moment, it's going to look something like that. So there's a square that they're asking you to sketch in part A. Now, let's continue. Let me grab a different color. In part B, they are asking you determine the vector components of the two diagonals. So one diagonal is going to be like that. So of course, if you look at the first diagonal, let's call this D1 for diagonal 1. This is really equal to applying the triangle law. It's going to be I plus j, I plus j. And of course, if you think about this, I is 1, 0, j is 0, 1, which really means the diagonal that we're looking at is going to be 1, 1. How do you double check that? You can go right by 1, up by 1. So that's going to be the first diagonal. If you look at the second diagonal, let's call this D2. And it could look something like this. D2. Let's call this D2. This is going to be negative I plus j. So again, this is going to be negative 1, 0 plus 0, 1, which means D2 is going to be negative 1, 1. Now in a different color, let's go back and look at the answer. So what they're really asking in this problem are the vector components. The vector components is kind of the major question. So really, you can look at it in terms of the following. You can say 1, 0 is one of the components, 0, 1 is the other one. It could be negative 1, 0, 0, 1. Notice those are not the only answers because when you think about the components, right? Again, 1, 1 and negative 1, 1 is if you draw the diagonal from the bottom to the top. But you could also draw from the top to the bottom. So I would say other components could also be, let me write them out in one box for you. So what we have so far are 1, 1. We also have negative 1, 1. But if you follow the same logic, you could say negative 1, because this could go from here to here. You could also have 1, negative 1, which means you go from here to here. So I've basically written down all 4 cases for you for part B, which describes the diagonal. Part C, verify that the angle between the diagonals is 90 degrees. First of all, we know that because by definition, a square has 4 90 degrees in it. And of course, you can apply the dot product. So what I am going to show you is one case, but there are 4 cases that you can demonstrate. So for example, you can take 1, 1, dot it into 1, negative 1. And this is going to be 1 times 1, which is 1, 1 times negative 1, which is negative 1, which is 0. So this implies the diagonals are 90 degrees apart. However, you may be thinking, can I use a different combination? What if I took 1, 1, and I dot it into, instead of 1, negative 1, you can say negative 1, 1. That's okay. You might be thinking, can I take negative, negative 1, dot that to 1, negative 1, or maybe you're thinking negative 1, negative 1, dot it into negative 1, 1. So again, there are different cases to describe the angle between the diagonals because there are 4 ways to express the diagonal. And you got to grab 2 of them, take the dot product to show that the angle is 90 degrees, just like that. I hope this makes sense.